assume you can see my screen. Well, GFS is not GFS paper. That was GFS paper. Okay. So let's look at this picture. So this figure has 5 program. That's your homework assignment number 2. So for homework assignment number 3, that we're assuming we have still 1 file, but we have 2 clients. We have 2 clients, and then they're using exactly the same replica, or you want to assign to different replica, that's okay. That's your choice. But essentially, you want to have some kind of synchronization issue because, say, one of the client number 1 is trying to access chunk number 1, and client number 2 is trying to access chunk number 2. And they're both trying to do this kind of computation. So just to let you know, a computation, design of the issue. For example, if you look at Emacs, what's that directory? No, wrong one. So if you look at the you look at the directory, it only have a 1 chunk called the chunk, right? That's because in homework 2, I only need 1 chunk, and that chunk is, I just have a 1 variable. So for homework assignment number 3, if you want to implement 2 chunk, you would say first chunk and second chunk, for example, something like that. Okay, so essentially you have a 2 chunk, but the duration should be the same because each of the chunk still have 3 copy, right? Whether the URL is primary, second A, second B, that's your choice. How many replica that you would like to create, and whether you can actually potentially implement, say, they share exactly the same primary, secondary A, and secondary B. Yeah. Does that answer your question?
Yes. Yes.
Okay.
Yeah.
Okay. Any other question?
So potentially we can have only 3 replicas and
Yeah,
two clients and 1 master.
replica, right?
Okay. Okay.
Yeah, I should tell you, the other day I went through this with one group of the student. You will realize that you make a very little change in client and the server. That's really little change you need to do. Sorry, client and the master, but you need to just adding a few lines. It's not even a huge chunk of code, but adding a few lines into the secondary A and secondary B and the primary. And you add a code in the virtual function, the JSON RPC function. You need to add a few lines of code, and you need to modify some code into the main function about that. I mean, just give you an idea. Let's see. So we have a few programs. One is master, right? So let's actually just look at the master. Master, I think, is almost done. You don't have to do anything. Okay, if you look at the master, this part is the same. And this part, actually, you don't need to change anything. That's the JSON RPC part. This part is just inherit from the code that's generated. I already make all the changes. And then this one is constructor. You don't need to change. And this part is almost, you can use it as it is obtain chunk. And over here, this 2 code, you don't need to change. If you want to do homework 2, it's probably because as a master, they should not handle push chunk to replica and commit or abort. That's actually the code looks like this is fine. Lookup, you can actually neglect that. That's actually, I left the code there because it's NFS implementation. This part you don't need to worry about. But then you have a main program, right? In the main program, you can see that I create a directory called mounted, which is the GF as a root. And then I assign the 3 chunk to the IP address and port number. So when you actually implement the secondary A, secondary B, and primary, you make sure the port number, they actually will accept incoming call is going to be 8300, 8301, 8302. Just like here, you see that this master is actually accepting 8384. So this number is called port number. So you need to modify. So master, I actually create a directory. So let's actually go to why I said main function, you need to change it a little bit. If you go to go to primary. If you go to main function, this one still says it's directory. So this part need to be changed. This part need to be changed to be the replica because the chunk, the replica is actually being defined in replica directory. So inside the replica, you have the chunk, right? You have the chunk over here, and then the replica will have committed data as a chunk and uncommitted data. By the way, since we're here, for homework assignment number 3, which you're going to change this to committed data chunk 1, uncommitted data chunk 1, and then you define committed data chunk 2, uncommitted data chunk 2, so you can actually support 2 chunks. That's probably the hack for you to quickly get that part to work. So this part will be replica, and then the port number, remember, it could be whatever number you want to set. I currently set it to be 830, so in fact, this part need to be 830 for master if you want to be consistent with that code. Okay, that's just basically do the pipeline, make sure that the program can talk to each other. Okay, any other question?
So Professor, with respect to the output, what exactly are you expecting to see?
Right.
For the obtain chunk URL, I get that we have a URL which is being returned as a JSON object, but for the other 2 functions, what output are we expected to show?
Okay. Yeah, you're talking about the output, that how the program will be executing, right? So we basically we let you decide whatever output you would like to produce. But for me, in fact, homework 2 and 3, I will ask TA to grade your homework. We're actually going to insert statement in each of the JSON RPC function. We want to see whether you call that function or not. So for example, if you're going to call, so you will see the sequence is the first, you're going to see that the master get called, receiving the 3 URL. Then we should see that the push chunk to replica. And then we are going to see, because we're going to add insert. Let me just give you an example of what I'm going to do. What I'm going to do here is that I will use this as example. So because of this replica, you cannot have obtain chunk. So it must be push chunk. So over here, I can just add std cout calling push chunk to replica \n. Okay, I can actually add this statement like this in every single function call. So when we actually check your program, we can see whether your program actually go through the calling sequence correctly. Then we know whether you have implemented the flow correctly.
Got it.
So
Thank
you don't have to worry about the code because we will add it to that. We'll try to find where you do this, and then we try to add to that. So of course, if you use C++, that's actually very trivial for us. If you use other programming language, we probably have to just basically try to find the entry point to insert the code. I mean, for homework assignment number 1, I remember when I grade some of your implementation, which is very different from the reference implementation. But actually, I think you guys are very creative. The student who actually implement, I think, is even better than the reference implementation. So we actually try to understand your code, and then so we can grade your homework 1. Okay, does that answer your question?
Yep. Thank you,
Okay,
Professor.
you're welcome. Let me check the chat. There's 6 questions here. That's strange, B0. I forgot where I used B0. Probably used my old habit I call it, use the C program. Oh, I do have B0 over here. Okay. Well, you potentially could have only 3 replica server, but you have, let me actually just use PowerPoint slides. Maybe it's easier to explain it that way. Okay, so let's actually worry about chunk first. So the chunk looks like this. You have a file, you have a 1 chunk, and you have the other chunk. Let me actually just change the color a little bit. Okay, so I have 2 different chunk, right? And for each of the chunk, I actually need to store on 3 server for pushing to the server. So I can potentially do that. Case number 1, I'm just having 3 server. I'm using a circle to represent the server. 1 server. And server number 2, server number 3. So you have 3 server. And the thing is that you could actually do either way. Let me actually try to. The first way to do it is just essentially move 2 chunk over here, and then 2 chunk over here, and then 2 chunk over here. So basically you have your primary, secondary A, secondary B, they both host both chunks. And therefore, we only need 3 servers. So that's case number 1. But case number 2, you could have something looks like this. I could actually add another 2 server. Just as an example, I can add another 2 server. Okay. And then what happened is that I'm going to move the second chunk over here. Can I move? Let me see. Yeah. Move looks like this. And this one, move over here. So you can see right now I have the scenario that I have 5 replica server. And this 3 server is actually hosting the 3 replica for the first chunk. And this, and this hosting the second chunk of server. So essentially that's your option. I mean, how many server you would like to create it? You can still using 3 if you think that's actually the most easy way for you to make a progress, then you should just use the 3 server. But if you like to try different thing, then you can actually create multiple server as well. Make sure they they will work as you expected. Okay. Does that address your issue about 2 server? Hello, let me check the chat. Okay, Francesco, you have some issue about the client constructor being undefined, right? Francesco, are you still here?
Yeah, sorry.
Okay, no problem. What's you still have an issue that when you compile the client constructor is not working? Is that the error you have?
Yeah, but I think I just figured it out. I wasn't using the Rosetta terminal, so
Oh, okay,
I
okay.
think that cleared it up. Thank you.
Okay, sure. You're welcome. Okay, any other question?
Yeah, I'm a little bit confused about the relationship between the chunk and a file handle.
Okay. A file handle is something associated with the whole file. With a file. For example, this file is a PowerPoint file, this file is a video file. So every single file has a file handle. It's essentially equivalent to a inode number. Okay, however, each of the file can be break up into multiple chunks. So in homework 2, you only have a 1 chunk. So essentially 1 chunk, so means the chunk number is going to be 1-to-1 to the file number. Okay, because you only have a 1 chunk, right? But however, in general, of course, that's not true because every file we're going to break into smaller chunks. A chunk is a fixed size block of storage that we're going to store the file. So that's why you can think about a chunk is just a part of a bigger file, while file handle is actually a unique identifier to the whole file.
So the file may take up several chunks, right?
Oh yeah, we could have a lots of chunk. Especially the file is getting bigger. So chunk is essentially, if you remember, I know, chunk is essentially the data block. So a file has a data block, right? Have a direct, indirect, double, triple, sorry, direct, single indirection, double indirection, triple is all pointer to the block, right? To the data block. So each of the data block is a chunk. So when I say you have 2 chunks, that means you have only 2 data blocks in your file.
So we're using 2 chunks to show the difference between consistent and
Right.
another. Okay, got
Right.
it. Thanks.
The reason you need 2 clients to do that is because it should happen in a way that both clients are trying to modify one of the chunks. So client A modify first chunk, client B modify the second chunk. So in this process, that you should actually realize that in order to make sure it's consistent, that means when you have any of the client try to read any of the file, try to do the read operation, regardless which replica you read, you're supposed to see the same value of the data. That's basically a consistent definition of consistent. And the thing is that if you cannot guarantee that, which when you have a failure that you're going to have some kind of inconsistent, and then that's basically just you can demonstrate through that.
I'm just a little bit confused about how can we simulate failures? Like,
Or just type Control C.
oh, to stop one of the servers or stop the
You
client.
can do Control C, or you can actually, I mean, there are multiple ways to do it. One is do Control C, but the other way probably better. Let me show you. I would, if I'm going to do the demo, I will usually do like this. For example, inside the primary replica, right? Let me see. Primary replica need to do push, right? For example, I need to do push. And in the middle of the push, I might say sleep 16 seconds. Okay, I sleep for 16 seconds. That means during the 16 seconds, the file has not been updated. And therefore, but maybe this is actually a bad idea. I shouldn't do this sleep 16. I should actually do a commit abort here. I do a 16 second. So it means that one of the replica already moved the data from uncommitted to committed. But this, because you actually insert extra delay, 16 seconds, which is represent a temporary failure of your system, and that will basically causing the issue. That will actually cause it inconsistent, because in this particular primary replica, I actually didn't actually write the uncommit data to commit, but secondary A, secondary B, they already did that. So then you try to pull the value out of the replica A or replica B versus primary, you're going to see different value for the data. Does that make sense?
Yes. And as for showing the difference between defined and consistent, I would like to know, let's say, since we're given 2 chunks for each file,
Right.
if one client, let's say there are 2 clients, client A and client B, if client A writes to the first chunk and client B writes to the second chunk, then there won't be any, so the file will always be defined, right? Because they're writing to different chunks, not the same chunk.
Not necessarily. That's the key thing. So if you let client A write to first chunk, and then you write the chunk 2 for, sorry, client 2 to actually write the second chunk, right? So consistent only guarantee whenever you try to read the file, they will be the same value. But define is actually be a little bit stronger. Define is essentially saying that whether you will see the same order. So when I actually write 2 chunks to the, sorry, I'm actually modify 2 separate chunks. My question for you is that which of this should happen first? If say both client 1 and client 2 want to modify the chunk 1 and chunk 2 respectively, my question is which chunk will be modified first? Is that the chunk 1 get modified first or chunk 2 get modified first?
Oh, so when you say undefined, it means so possibly right after client A has modified the first chunk, and then someone tries to read it. So there will be so the order would matter in this case, right?
Right, right. So let's actually make things more. Let's actually use. Let me see which one I should actually use this directory. Okay, let me actually use the previous slide. It's probably easier. Okay. So I'm actually going to write the old value a new value. Okay, so before you write the value blue and red, I'm actually going to use this to represent an older value of this two chunk. Okay, so now I'm actually going to use a different color. I'm going to use some color which is a little bit lighter. Okay, this represents the older value, and this one I'm actually going to use also a lighter value for that. Okay, so the lighter color represents the old value, and the dark color represents the new value. You have a two chunk simultaneously. You try to write to that, right? Okay, so consistent is just saying that, well, when I read this chunk in 3 copy, I'm actually going to see the same result. Then that's actually consistent. But define, I actually want to see the order of this two. Which one got converted from the light blue to dark blue, light purple to this is just I don't know how to call this color. Maybe it's a yellow to the red color, from the lighter color to the red color. What's the order? Why the order matter? Let's actually write down the order. If the order is chunk 1, then chunk 2. If this is the order we want to follow, then essentially you can have this. You can actually have this state. You can have this state, but let me actually change this color a little bit. I want to have, because chunk 1 happened first, so this is also acceptable as defined. Okay, this is a defined because why? Because the chunk 1 actually first modified to this, and then chunk 2 hasn't modified. So this view of the data is actually defined based on the order. Okay, well, then what's undefined? This is undefined. I'm going to put it here. This is undefined according to the order. Because if the order is chunk 1 and then chunk 2, and how can you still have this data when I try to read it? So this is actually undefined. So what do I mean by defined in GFS? Meaning that if one of the replica or one of the server, when they have this chunk 1 versus chunk 2, they actually take this order, chunk 1 to chunk 2, then in every other replica, they should actually follow exactly the same order. That's what define means. So define is looking at a sequence of write operation to the whole file, while consistent only care about one single chunk. At any time, when I read that chunk, they should be the same value. But only define, you can actually say this particular value will never occur because it's undefined. Okay, I should say this. The reason that this is unacceptable or undefined is because you actually choose chunk 1 and chunk 2 as order for a sequence number, decide which one will go first. And if one server has this order, then all 3 servers must actually have the same order. So that's the concept I want you to. In fact, I know why I want you to do the homework assignment number 3 is because I want to make sure that you understand this concept, which is not very trivial for anybody to understand the difference between defined and consistent.
So for the two rectangles on the right side, which is undefined. So may I know if that's consistent?
If there is no failure, yes, it is actually consistent.
Oh, okay. So what if two clients write to the same chunk? So do we need to handle this case?
Yeah, if it's two file write to the same chunk. Okay, first, you don't need to, for homework assignment number 3, you don't need to handle that case. Okay, for homework assignment number 2, if I remember what I said in the assignment, I'm actually talk about two clients writing to two different chunks. Having said that, I was just talk about the homework assignment. Now I'm going to talk about how you can handle this. Of course, that a correct implementation of GFS will be able to handle that as well. So you have a two requests simultaneously is going to write to the same chunk. So in other words, now I'm going to copy this slide to this. So what you described is this particular scenario. So now I have only one chunk, so I don't need to worry about this. I get rid of this, okay? Okay, so assuming, let's actually change my notation a little bit. Let's say this is the O value. Okay, this is the O value. And assuming this is the value that client 1 want to actually change. And this one, I'm going to change the color again. Let me use purple. Okay, so you can see that you have an O value, you have a client 1, you have a client 2, right? So essentially now client 1 and client 2 want to actually write their data to the server. So the thing is that when GFS, when you want to write the data to all three servers, it has to be for both consistent and defined. You have to do this. You have to make sure that they actually follow. Hold on one second. They need to actually follow exactly the same order. Looks like this. Okay, so that is actually a consistent, and both a consistent and the defined, because they're actually doing this the same order. What's not a good thing is one of the server you actually swap the order like this. Then this become undefined. Sorry, inconsistent as well. It's not only undefined but also inconsistent. Because when you actually read the three copy on the same chunk, they're actually going to have a different column, different value, right?
Yeah, just to clarify the difference between defined and consistent, because in my note, it says that consistent means all replica have the same data, but the mutations might not be applied in serial order. So, but if it's defined, then all replica will still have the same data, and the mutations are applied to the file in the serial order. depend on which client calls the right function first, right?
Right. That's correct.
So consistent means at some time it might be the case that since there are two mutations by two different clients on two different chunks, so it might be the case that client one has says do commit to actually write to perform the mutation, but client two has not done the do commit, which means if other clients trying to read the file, then that other client could only see the mutations by client one, but not client two. But at that time is the file is still consistent, right?
When GFS define consistency, or a lot of this kind of two-phase commit, when they define consistency, it always has assumption is that you will pass that window, a small time window for every server to update the value to the newest one. So essentially, there is no system in the whole world that actually can guarantee the consistent on every single second. It is impossible, by the way, even without failure. As long as you have network delay, as long as you are not deterministically be able to say have an absolutely synchronous clock. I mean, how do I mean, okay, let me actually tell you a theoretical model, never practical. So a theoretical model is that assuming every single machine, every single server has a clock, and that clock is perfectly synchronized. In that case, you can potentially say, okay, at 12 o'clock exact, every replica is actually write the new value, exactly 12 o'clock. So that's the only way you can guarantee that anytime you go to any of the replica, you're going to get the same result. So therefore, because that's actually just not practical. I mean, no matter how good you are, try to synchronize your clock is going to have a small probability, it's going to have a little bit gap between each other. So therefore, the assumption is always that after a short amount of time, we do not even specify how short that will be, because that's actually depending on a lot of factors. So we're actually assuming that there is a small period of time that's the system is going to be inconsistent, but after you pass that period of time, that the system should stabilize. When they stabilize, converge, then you're guaranteed you're going to have this consistent, you're going to have this consistency criteria over there.
Oh, got it. Thanks. So consistent and defined all means all replica have the same mutations performed, but I mean they have the same data, but only difference is whether the data is, whether the mutations are applied in order or not, right?
Yeah.
Okay, got it. Thank you so much.
Yeah, define is looking at the order of the mutation.
Got it. Thanks.
Okay. Any other question?
Hi, Professor.
Yeah, go ahead.
I have a question about the client interaction with the master. So the master should be called the function obtain chunk URL to get the URL of 3 replica, right?
That's correct.
And the app handle you use in the code, the default is all 0, but in the call of the master, if you send this app handle into the attempt chunk URL, you probably will get GFS error.
Yeah, you will get GFS error. Yeah, you need to modify. I forgot which place you need to modify. Either you modify both sides to be 0 or both sides to be 0, 2. Yes.
Okay, I just want to mention that.
Right.
Thank you.
Thank you. Yeah, because that was the checking. It will actually check. If you don't change that, the server will say, hey, that's not recognized. Yeah. So, but by the way, I actually want to tell you that there are at least 2 or 3 places which you need to change things like this in order to get it to work.
Okay, thank you.
Okay, any other question? So let me actually, I think who asked the previous question? I'm sorry, I didn't get your name. Who just asked me the question about modify the F handle?
Oh yeah, I did.
Yeah, because I cannot see anything on my screen. What's your name? I cannot see. I cannot.
Hindu.
Hindu.
Pintin is P-I-N-T-I-N-G.
Oh, Hinpin. Okay,
Yeah,
Tim.
yeah.
Okay, thank you. I want to actually just tell everybody what he was talking about, so you can actually learn from this particular answer. So let me just do this. Let's go to mini GFS client. So you can see that when I actually call GFS master obtain chunk URL, you see that I'm actually, instead of putting 0002, I actually, the second parameter, I put 00000. I put all 0. Okay, this is when I call from the mini GFS client. But if I go to mini GFS master and go to obtain, okay, now I'm actually calling this obtain function. So inside the obtain function, the first thing I'm actually trying to check is F handle. If F handle is not equal to 02, I'm actually going to send back the status, say GFS error stale, right? So because when I call this, I'm actually using the second parameter is actually F handle, and then I'm actually putting 0. So this one, you're going to hit this one for sure. So in order to avoid that, to actually do the real part, to call mounted obtain chunk, you have to change this part to 2. Okay, so this number here must be the same as whatever number I put it here. That's what he was asking. Just want to make sure everybody got it. Okay. Okay, any other question? Oh, by the way, I want to ask you a question. Because I think most of you are either PhD student or master student. Did you receive an email saying that we have a faculty candidate who's going to give a talk today? Is that right?
Yes, that is correct.
Yeah. When will it start? 3 o'clock?
3:10.
3:10. Okay. So let's start my office hour maybe after his talk or his or her talk. Okay. I mean, I want to encourage all of you to go to his talk. It will be virtual. It will be very interesting. It's a software engineering or programming language candidate. I think you should go there. And then I might or might not go there because I still have some deadline I try to catch, but I try to pop in as well. So let's have office hour after his talk finish. Okay, probably let's just say 4:20. 4 o'clock. Oh, by the way, I want to ask the other thing. Did you guys got scheduled to meet with a candidate virtually right after his talk, like we had before?
Yes.
Okay. Wow. When will be the meeting time? From 4 o'clock to when? Anybody have any idea?
Yeah, it's officially until 5, but
Okay.
usually the candidates talk to the inviter at like,
Okay, so let's
4:50.
start at 4:30. The office hour
Okay.
today is 4:30 to 5:30. Will that be okay? So at least you have time to participate a little bit about. It's actually very important for you to participate this kind of event, because some of you might want to be faculty one day. So it's very important for you to learn what happened during a recruitment or interview process, because you guys some of you, not all of you, will need to go through the same kind of interview when you graduate with your PhD degree, okay? You're all very welcome to attend those events. I mean, some of you might be a master's student right now, but later might change your mind to be a PhD student. Okay, any other question? Wow, silence.
Yeah, since no one is asking, I would like to ask one.
Of course.
So this question is still regarding to the difference between consistent and defined.
Okay.
Since if we are modifying different chunks, why would the order of the mutations applied matter? Because from my point of view, if the file consists of several chunks, so those chunks will be separated. And if those chunks are separated, then it means they are kind of independent with each other. So why we would care about the order of the mutations applied in this case?
Well, I will use this example to show why it matters. Let's actually try to provide the value for each of this chunk, assuming this value is, so in this picture, the darker value is the newer value, right? Assuming this is 3, this one is, wait a minute, okay, yeah. This one is 4, and the original value is actually 1, and this value is 2. Okay, so the original value is 1 and 2, and then after the modification, it should be 3 and 4. Okay, that's basically when you actually allow 2 clients to modify the both chunk around the same time. Okay, not exactly the same time, but they're basically modified at this time. So if I actually do this kind of synchronization, chunk 1 and chunk 2, then essentially it's possible, because chunk the first chunk was modified first, so you actually have the value that's actually to be 3, and this value is going to be 2, right? So that's actually possible when you actually go in to read it, because the first one is done, the second one hasn't occurred yet. So you potentially can actually see the 3, 2, right? And however, this one is a value of what? Is 1 and 4. This is essentially 1 and 4. So if let's actually say, if somehow this replica is actually doing chunk 2 and chunk 1. Okay, assuming the order is different between these two, then essentially you could have a value of this 2 chunk, and such that they are inconsistent. By the way, it's actually over here as well. It's the same situation for this 2 chunk, but it is inconsistent. It's a consistent because anytime you actually go there to read, if you only care about chunk number 1, that you're going to either reading 1 or reading 3. Remember, we say you have to wait a little bit until eventually, because eventually, let me actually put the order of the time so you know what I'm talking about. Let me get rid of this. Okay, so you can see that this is basically the old state, and this is the new state. Okay, from here to here, I can actually go to here and then here, or I can actually go to here and here. So if you only look at one chunk, it is consistent because no matter how you're going to read all 3 files, they should be the same value. Yes, there is a short period of time that 1 and the 3, you actually have a little bit overlap, but after 3 is fit because this guy got modified first, and then this guy modified over here. So eventually, that this 2 is going to be synchronized to be 3. But what's defined is trying to look at a sequence of mutation must be follow certain kind of order serially. This is not parallel modification. This is a serial modification. If you look at the definition of defined and consistent, if you do parallel, that's a different definition than you do a serial. If you do serial, you have to choose either chunk 1 to chunk 2 or chunk 2 to chunk 1. If you actually, this one, you actually do chunk 1 and chunk 2, and then this one, you do chunk 2 and chunk 1. Then essentially there is a period of time that the semantics about the whole mutations that you are doing is actually going to create a 2 different view about the same data. So even in the middle, this part is transient. It's a very short, but define is trying to make sure that even that short discrepancy won't occur at all. So that's the difference why when you modify 2 different chunks, if you're doing a different order, is unacceptable because I'm actually looking at this file. I mean, think about it this way. This could be the whole file, only have 2 chunks. This is one state I'm acceptable. This is the state I acceptable. That's acceptable to me. But between this one and this one, I only want 1. I only want to make sure all 3 of them will fall onto 1, not both of them. That's what define is trying to emphasize.
Got it. Thank you. May I know how we could implement the concurrent writes? So is the concurrent writes means both client 1 and client 2 are trying to write concurrently, or client 1 is trying to perform 2 writes concurrently?
Concurrent write means both client 1 and client 2 try to write to either the same chunk or different chunk.
But my thoughts is if client 1 and client 2 are both trying to write to different chunks, like what assignment 3 discusses,
right?
So to some extent, internally the primary replica, I mean, all the replicas will have a sort of like a counter to record which one arrives first, which means which client writes first. So to some extent,
no, that's parallel.
That's parallel?
If it's a parallel, then you basically, you can write to whatever you want, right? I don't care about which one goes first. In
Oh.
parallel, you don't worry about that. In parallel, you don't worry about this order. It's only sequential you worry about this order.
Oh, so if it's concurrent, right, then we do not need to we do not need to distinguish whether
It's
defined.
not going to be defined. Yeah,
Oh.
let me actually pull out the definition of this from the paper. Probably clarify this is easier. There's a table. Oh, I passed it. Sorry about that. You see here? Maybe let me make a,
Yeah, I see that.
yeah. So if it's concurrent SS, is consistent but undefined. It's only when you have a serial is defined. You see that? This is the difference.
Yeah, I see that. So does that mean we need to sort of like get two versions of write function? One is called serial write, the other one is called concurrent write. And so that if we want to emulate the behavior of serial write, then we call serial write in both clients. And if we want to emulate the behavior of concurrent, we do that.
So there are multiple ways you can actually do this. But the easiest way for you to do this is to synchronize at the master. The easiest way to do this is synchronize at the master. When you actually obtain this three replica, and the master is actually going to give you a number for you to actually decide that what is the serial number, or you can actually synchronize this at the primary if the primary actually be able to communicate for both chunk 1 and chunk 2, which is not necessary because the primary doesn't have to be always together. So therefore, it's better to actually synchronize at the master index server. So client 1 will go there, will obtain like a logical timestamp. And then the client 2 is going to get a logical timestamp when they request the URL slightly bigger than the first one. And therefore, when they write to it, if there's only one write that's actually coming over, then that's okay. But if they have two writes come over there, then the replica need to make sure that this two write requests will be synchronized according to their sequence number.
I think there might be an edge case where client 1 contacts master and then get the, let's say, serial order number 1, and then client 2 comes and get the serial order number 2. So but client 1 doesn't do it, right? Instead it sleeps for several seconds doing other stuff. Then what if at that time, during that period of time, client 2 writes to that, and what primary replica gets is an order of 2, but didn't even receive the order of 1, which belongs to the client 1. So in that case, how could the primary replica how could they know that there will be a client 1 coming later?
Okay, let's actually come over here, use this as an example. So what you're saying is that we're saying that is assuming we're doing chunk 1 and then chunk 2, okay? Would that be okay? Chunk
Yeah, sure.
1 and then chunk 2. So what you're saying is that this update is actually, this guy is actually sleep, right? Why have a 3? Okay. So this one sleep for whatever amount of time, right? So this one is already done, right? This one is, you're saying that this one actually go to 2 and then it's go to 4 directly, right?
Yes.
Because this one come here, so he got to 4. But this one, because the sleep is actually still 1 over here, right? So essentially, your number 2 is already get to 4, while you are actually still in the previous mode, right? So this is actually only possible if that sleep time is very short. Remember that all the GFS, they assume that these things will happen in a short period of time. If you wait for too long, then you have a short period of time, you're actually going to have this. And that is the reason is you sleep too long, which is what's the sleep too long? That's actually a failure. That's not a success state. If it's a failure, then essentially it cannot guarantee a define, even you try to do serial.
Oh, so to some extent, what you mean is the order. I mean, as long as or as soon as the client has contacted the master, then the client. I mean, as long as client has received the URLs of the 3 replicas, then the client will immediately push all the data to all 3 replicas without any wait, right?
Let me use this figure to explain what I just talked about. If I distribute this 3 replica in this configuration, which means that in this 4 machine, there's only just 1 replica, right? Sorry, 1 chunk. Only this machine has 2 chunks, right? Only this machine has 2 chunks. So essentially, the only place that you're going to have that serialized, this kind of serial order issue is when this machine, you have 2 requests simultaneously want to make a modification for these 2 chunks. And over there, you have to synchronize that. And for this, it's okay because it's actually on a separate machine, and you cannot do any kind of synchronization over there.
Oh,
It's
so
only in this case you have to deal with that when they actually on the same replica.
so does that mean if we choose to only use 3 replicas, which means 2 chunks on each replica, then the implementation will be a little bit
Easier. Yeah, that's true.
Oh, okay.
Yeah, that's why I hope you have at least 1 replica which has both chunk.
Got it. Thank you.
You're welcome.
Professor, I have a question.
Sure, go ahead.
So it's about the commit abort function. So in the replica.cpp constructor, there is no commit abort parameter. So when we are creating a replica in the primary, how do we pass either the commit or the abort to the function? Because that parameter is not there.
Let me actually check. Are you sure it's not there? Let me actually check.
In replica.cpp.
Yeah, I have to do replica.cpp, right?
Mm-hmm.
So here, replica commit or abort, the last argument is commit or abort. That's the argument. So let me see, do I have a code here? Okay, you see here, what I did is if the commit or abort is equal to commit, then I'm actually writing the uncommit data to the committed data. Is that what you're asking?
I w- is I was asking in the constructor itself. Oh,
Oh, the constructor, don't worry about that. Constructor doesn't, constructor is just creating that replica. It's not doing the commit or abort. Commit abort need to pass only the function commit abort.
So, Professor, just following up on that. So when we create the replica within the primary, we aren't passing the commit abort parameter upon creation of the replica, but we are passing that parameter when we are calling commit abort.
Yes, that's
Okay.
right.
Okay.
So the order looks like this. The client is going to first, let me see if does my client has that code already. Okay, you see, this is the client code. Let me actually tell you what the client code is doing. So I basically see I push the replica, right? I push the data. The data is ecs251 data, is my chunk data. I push my chunk data with the file name, f handle, and index, chunk index. I call push chunk to replica to the first one, primary, and to the secondary B. So after I've done that, this is the result. I got result P, result A, result B, correspond to the result I heard from primary, result from replica A, replica B. I look at the one parameter called vote. If the vote is all three of them is commit, then I'm going to call commit abort, but the parameter is commit. If I should probably do this, I didn't do it here, is that else I could do this. I could just I can do like this, right? So if everybody voted commit, I'm going to ask each of the replica to do commit. But any other case, I'm actually going to do abort.
So now that this is abort, wouldn't the I think replica.cpp change, because I think there's only one condition which checks.
In my case, I don't have to do anything
Okay.
because as long as I don't actually write the data to the committed, from the uncommitted to the committed, that's fine.
Got it. And so with this, when in primary, what exactly do we have to do? We just have to create a replica and then call push to chunk replica, or?
In fact, the primary, it just create the replica and that's it. So after you create the replica, everything becomes so passive. So the primary is actually, they just need to listen to the whatever the client want them to do, right? If the client don't call them any function, the primary does nothing.
Okay, got it. Thank you.
Yeah, it's just a storage. So you can think about primary, secondary A, secondary B, especially right now our design is actually make their role is equal actually. So we actually have some kind of earlier when Stan asked the question, some of the confusion is because we actually have three replica, they are actually equal role. That's why we have some of the issue there. But basically, we let the client to drive this.
okay. Thanks, Professor.
You're welcome.
So that means we could put shadow replica in primary replica that connects to both secondary replica A and B.
This is all shadow, in fact.
Okay, got it. Thanks.
You see here, this is a shadow. This is shadow replica. For client is a shadow replica, but for the mini GFS primary.cpp, that's actually going to be real replica.
Got it.
Okay, so we're past 3 o'clock already, and I think at least some of you might want to go to the candidates talk, and we will continue for this at 4:30. Okay. Okay, Annie, I will post this as soon as possible. Okay. Okay, I'm going to stop it.